Were you the first person to come up with the theory that the pyramid was a power plant?
Guilty. Let me back up a little bit. There was a general period of time in the 70s where there was a lot of interest in something that they call pyramid power. In that the pyramids had, just by the shape of a pyramid, it had this kind of energetic value. So there was a lot of talk about that. There was a book written by Patrick Flanagan back in the 70s. It was called Pyramid Power. There were other books written that referred to the Great Pyramid with talking about pyramid power. But it was a mystical kind of power rather than a practical.
Mystical, how so?
Something that was not quantified in physical terms, or three-dimensional terms.
Not measured.
Not measured. It's more like something that we didn't quite understand, couldn't quantify.
And was that based on like people standing in the pyramids? And
it's based on a lot of that kind of information, or those experiences. It was more an experiential kind of an experiential experience. Scratch that.
Right.
No, it was more an observation. And
subjective
in a lot of ways. Some of it was, they tried to measure it, but they were measuring effects rather than identifying what kind of energy it was.
Okay.
The sharp and razor blade experiment was very popular back then, where the pyramid was said to, if you put a razor blade inside a pyramid shape, then the blade would stay sharper longer.
What?
Yeah. So it had a lot of different values.
Is that true? Does the razor blade stay sharper longer if you keep it inside the pyramid?
I tried that. I did it. I said, well, I'm going to try it. So I used a razor blade for a little longer than I thought. But then I had the thought in my mind was that doing those kind of experiments, those are already done. What was needed was a complete kind of reverse engineering of the structure to determine and find answers for every single part of it.
Right.
What was originally designed into it, what was introduced afterwards that was not a part of the design, what the operation of the pyramid, what effects that may have had in certain areas. And so there was quite a lot of information that I had to go through to find answers for. A lot of mystery. But the thing that struck me the most is the incongruity of the shafts, the small shafts. There's a story behind those that is quite exciting, really. But they're really important to the function of the machine. So yeah, all of that struck me immediately with the precision, just the angles, the different shapes. It was all very machine-like to me. And I think, when it comes to saying that the pyramid was a machine to produce energy, then yeah, I was probably the first to actually put that out.
What type of machine do you believe that this pyramid is, and how does it work?
In my First book was called the Giza Power Plant, as you know. And
Yes.
okay, so the Giza Power Plant described the Great Pyramid. I described it as a coupled oscillator, in that it was connected to the Earth. Its proportions were an integer to the Earth, and it was tuned harmonically to the vibrations of the Earth. That was what I proposed. And as such, it reacted to the Earth's pulse or the Earth's hum vibrations, and through that they were able to stimulate electron flow in the central granite chamber, and produce microwave energy. So basically, I described it as a maser, but it was
A maser.
like a solid state maser.
A solid state electron harvester.
Well, that's what ultimately I called it. Yeah, it was a electron harvester. And so that was in my first book. I didn't call it electron harvester.
Oh, that was until the new book. Okay.
Yeah. Well, I realized that, a lot of people will look at the word power plant, and the vision that comes to their mind is like smokestacks,
Right.
long trains of coal snaking through the countryside to these power plants. And so, kind of, and then of course, power plant, a nuclear power plant, coal power plants,
Right.
and stuff like that.
Right.
So it's generally associated with boiling water, creating steam, pushing turbines, and drawing the electrons off the generators. But the this was kind of like a different concept in terms of creating energy or drawing energy from the Earth directly, without burning fossil fuels or smashing atoms.
So underneath, in the cover of the Giza power plant, you have the pyramid sitting in the desert, and then underneath that, you have like it looks like lava underneath, and then like the crust of the Earth. So I guess you're describing that seismic activity that's happening inside of the Earth, creating vibrations that are resonating with all the rocks in the pyramid.
Yeah, that cover was created by my publisher, Bear and Company. They're artists, and basically it does represent what you just said.
Okay.
As far as strict accuracy to engineering drawings, that you don't see that there, but it loosely gives you an idea.
Okay.
Right. It represents the pyramid, energy coming out of the pyramid, its connection to the Earth, and energy going on inside the Earth that is tapping into.
So you theorized that the pyramids were harvesting energy and generating energy to power whatever civilization created them.
Yeah.
And how do they get power from the pyramids?
How do they get it?
How do they use it?
Oh, how do they use it?
Yeah.
That is a good question. It's a question I get asked a lot. The problem that we have is when you look at the pyramids, so you go to Egypt and you walk around the pyramids and the temples, you look at the skeleton of a civilization. Obviously, there's so much that's missing, that has disappeared over time.
Right.
We don't know why. And so when you ask the question, well, what were they powering? We don't find any microwave ovens out in the desert. So, and you probably won't. The only thing that really survived from that period of time was
The rocks.
The rocks.
Yeah.
Right. So and some other materials, but the rocks basically survived. And it's a matter of then again, it's like, okay, so what we're left with is the rocks. So what do? We take measurements. We look at the design. We analyze the effects of certain spaces, like the King's Chamber, the effects of that chamber, with the acoustic effects of it, the acoustic effects of the Grand Gallery. So there's a lot that we can study to try and come up with some answers as to how it functioned, what it did.
We're looking at the Queen's Chamber right now on your slides.
So we talked about the hydrogen explosion, and it would be probably a good thing to talk about the where the hydrogen was created.
Yes.
And why hydrogen is considered to be the gaseous medium where maser activity takes place.
Okay.
So if we look at the Queen's Chamber, it had two shafts. In 1872, Wayman Dixon detected a crack in the wall and found that he could push a rod through into perceivably an open space. So he had the limestone chiseled out. Initially they were not connected to the chamber.
Really?
Right. See, that's a very, very important point, is that there was a 5-inch, what they call a 5-inch left, it's been called, where the shaft was cut almost to the inside wall, but 5 inches remained. Then there was a crack. So there's your 5 inches, there's your crack, right? Then in 1993, Rudolf Gantenbrink explored this shaft, and he found that it ended at a stone block. Okay, before I go further with this, I should add that Wayman Dixon also opened up the northern shaft, by tapping on the wall and detecting a hollow space directly opposite the other shaft. He chiseled the limestone out there and opened up that shaft. So you got two shafts that are closed off at the chamber. They don't connect with the chamber. They just have that layer of limestone.
Why do you think they weren't connected to the chamber?
There's a reason for that. I'm getting to it.
Okay.
All right. Good question.
Thanks.
So anyway, when Gantenbrink sent his robot up, he found what has been known as Gantenbrink's door, right? Everybody's heard of that. And then through the door, he saw that there were two fittings, metal fittings. I haven't read any metallurgical analysis of what the composition of the material is here, but they have some very unusual features. Number one, which is important, is that the one on the left here that you see here is shorter than this one. And they found a piece of it that was on the shaft floor further down from it. So it had broken up or dropped off.
Okay.
And fell down, right? This one was intact, and but you can see that it was tapered from the top to bottom.
Right.
You see a little tapering on that.
Right.
Okay, so there is a reason for that. So essentially, once that was discovered, and they were talking about drilling a hole through that limestone block, it's called a door. That shaft is only like 8 inches square. So a door for what? There's
no one
it's just a misnomer.
Okay.
I think Hawass was involved in that, and a door. It seems like, okay, we'll call it a door because maybe Khufu's tomb is behind it.
There's some treasure back there.
Yeah, so it's a door to some other mysteries.
Right.
Right. So anyway, when they were testing the thickness on the door, I had published in my book this image right here, and basically I had speculated that behind these copper fittings or whatever material they made of,
Right.
were connected to some cables that went down to a chamber, and the reason for the copper fittings or whatever the material was to create a circuit. They served as like a fluid switch. So if you can imagine, like, what is the purpose of these shafts where they're closed at the bottom end and closed at the top end?
Right.
Why? What would they be using?
Right.
What would pass through there? There's only one substance that would pass through, and that is a fluid.
How would a fluid get into a closed-off shaft with no openings? Well,
that's it. They had to have been pumped from below, from somewhere below, right?
Okay.
And so the two chemicals, there was a chemical engineer that worked at the company I was working at, and his name was Joe Drewski. And I said, well, okay, what two chemicals could I mix to produce hydrogen? And he gave me a formula for it. It was hydrated zinc and a dilute hydrochloric acid solution. Okay. So looking at the erosion or corrosion of the of the pins, and considering the operation, you have a layer of fluid that is covering the pins, creating a circuit. Okay. And so electricity flows from one of those, I call them electrodes. One of those electrodes to the other, electricity is flowing.
Okay.
Okay. And so that signals a closed condition.
Okay.
All right.
Okay.
So when the fluid drops below the level of those pins, then the circuit opens. Now, what is important is the metering of this fluid into the chamber. And so, I'm gathering information from numerous sources, right? I was puzzling over the Queen's Chamber shaft, and I was talking to a civil engineer. He was doing percolation tests in the property I had in southern Indiana. Well, southern Indiana has a lot of limestone, as you know, right? And so I was out talking to him as he was doing a percolation test. And basically what that is he digs a hole, right? And then he fills it with water, and then he times the disappearance of the water to determine how many cubic feet that you would need to handle a septic system, right?
Okay.
For a house.
Okay.
And so basically, your fluid waste goes into a septic tank, and then it's dispersed through these runs that will distribute it through several pipes and into the surrounding soil. So I asked him, I said, well, what do you do if you're doing a percolation test around Bedford where there's a lot of limestone? What happens then? So you dig it into limestone? Do you still drill a test hole and fill it with water? And he said, yes. I said, really? He said, yeah. They said, you'd drill your test hole, and then you would determine what the dispersion rate is, or the percolation rate. And I said, well, okay, that's interesting. And what determines the percolation rate? He said the head pressure.
The what pressure?
The head pressure.
The head pressure.
Right. So really, that is the weight of water, or the weight of the fluid that's pressing down on the limestone, pushing it through the limestone. You got it?
Yes. So it goes through the limestone
Goes
at a
through
certain
the limestone at a certain rate. But in order for that rate to be precise and continuous, the head pressure, or the column of fluid, has to be maintained at a certain level.
So how exactly does the fluid get in there? It gets in through these two things?
Well, no. It would. I propose that there was behind this particular limestone block. There would be a vertical shaft going down to the bedrock, and where you had the equipment necessary and supplies necessary to pump more fluid behind the Gantenbrink store, and then replenish the shaft and maintain that level.
And it replenishes the shaft by going through the limestone, which is the door?
No, there is a gap underneath the door, and there's also a notch on the side. So yeah, there won't be any problem with it going through there.
So
another point I want to make is that, a part of the evidence to support that idea.
There's a gap under there?
Yeah, there's a little notch in the corner over there.
Okay.
Is those pens are tapered top to bottom. They're thicker at the top of the bottom.
Right.
Right? So if you've got a corrosive fluid that is covering those, and then slowly dropping, then you would actually have a corrosive effect that would leave a taper, because the lower parts of that pin would be submerged longer than the upper parts of the pin.
Right. And then when the fluid gets below the pins, not touching it anymore, that's when they're triggered to fill it with more.
Right. Exactly.
Okay.
Exactly. And notice this kind of substance around there. It's like an insulation. Mm-hmm. Right. Well, this becomes a little more interesting as we get into further research.
Okay. Let's talk about the Petri core.
You want to do that?
Yeah. Now, you were the first.
You're saving the worst to last.
You were one of the first people to get your hands on this Petri core and measure out the grooves around the edge of it and run a string along it and determine that it was actually a spiral groove, not just horizontal grooves.
No, actually, William Flinders Petri was the first.
Right.
Right.
Duh. I thought it was called Chris Dunn's core number 7.
Yeah, no, it's not. Petri core number 7. Yeah, I really caused a stir with that, didn't I? Mm-hmm. So I was riding the Giza power plant, and like I said earlier, a friend of mine recommended that I submit an article to Analog Magazine, which I did, and it was published in '84. So that was called Advanced Machining in Ancient Egypt. Mm-hmm. And in that article, I referenced the Petri core and relayed what Petri wrote about it. That it was a tapered core, came out of a hole, presumably, that exists in the Valley Temple, and that it had a spiral groove, that the grooves were 100 thousandths distance apart, and that he checked like 4 turns of it, and claimed that it was a true spiral. And he also said that the groove was cut deeper in the quartz as it was the feldspar. Okay. So when I was trying to figure out, using my machinist tool-making background, what kind of technology could create those kind of features,
Right.
I proposed that perhaps they had used ultrasonic machining, because ultrasonic machining is not, it's not like a conventional type machining where, conventional drilling of granite, as I learned from an ultrasonic or a conventional granite manufacturer, Ron Granite in Ohio. They conventional drilling holes, the penetration rate was like 2/10,000ths of an inch per revolution of the drill.
2/10,000ths of an inch per revolution.
So if you look at 100,000ths per revolution, that's like 500 times greater than than conventional drilling.
Okay.
It's an impossible feed rate in granite. And
you can figure out the rate by the distance between the grooves?
Yes.
Okay.
Right. And that's where the controversy began, is that I proposed a method that was totally unacceptable, ultrasonic drilling, which is where you use vibration to impact the granite and remove material, and then advanced the tool into the granite using a screw and nut method, as you can see there with the capstan at the top, and you just put pressure on it, moving it into the granite. Use a slurry, which will actually do the cutting. And then there is a taper on the bore and the outside of the tube drill, and that taper, the tube drill will wear as it is penetrating the granite, and that is reflected on the core and the hole as a taper, right? So that was just my idea, just a simple idea.
Mm-hmm.
It received limited attention in after the article was published. There was a couple of protests, one by L. Sprague de Camp, who objected to it. He wrote a book called The Ancient Engineers, and so he claimed that, the working of stone by the Egyptians is well known, went through the whole list of, copper,
right,
copper tubes and bashing stones and stuff like that. So I responded to his email, and then that was pretty much it. And then in 1995, I was invited to participate in a message board discussion on Deja News, and there was a guy called Rodney Small who had read my article in '84, and evidently it had become a point of discussion on the Deja News alt archaeology message board. So I joined in, and that was my first taste of message board discussions. And
wow.
Yeah. And so after, I don't know, maybe 1,000 or so posts, it kind of petered out. I don't think anybody changed their position on it.
This was what year, roughly?
1995, I think.
Ooh.
Yeah.
You've got mail.
You've got mail, right? Yeah, the old key.
Yeah. That was before that, probably.
No, it was actually 95 when I first got online.
Oh, was it really?
Yeah.
Oh, wow.
Yeah. Yeah, so I was on AOL. I'm still on AOL.
Are you really?
I know, people look at me strange like that when I say that. Yeah, I'm still
Good
on
for
AOL.
you.
Still have the same email.
Still holding strong.
I don't know about strong. Holding.
Okay.
All right. So then, after that, there was a book published. It was by Chris Ogilvy Harold, and a guy called Lawson. Oh, I forgot his first name. I'll think of it. So anyway, they wrote a book called Giza the Truth, and in that book they report on an examination of the core by two people, Reed and Brownlee, who go to the Petri Museum where the core is located, and they determined that it's not a spiral, that it's a horizontal groove. Okay. So I looked at that, I read that, and I was like, well, okay, interesting. But it looks like the core is slightly tilted, and that would kind of throw you off when you're trying to visualize the core, the spirals. And it's, yeah. So I was still on Petri's side, but I was willing to be proven wrong, right? But not just with that photograph. So knowing where the core was, I arranged to go to the Petri Museum and inspect it myself. And so I went to the Petri Museum and I wrapped a thread around the core. Oh, I righted the core. You can see it tilted on the left in the same way that the book shows it. And then on the right, I squared it up to the frame.
Right.
And then in my book, I
it's
included
exactly the same thing. Yeah.
Included this, which is a common pipe thread. It shows you how just a slight tilt on a pipe thread you can turn a spiral into a horizontal very easily.
Right.
It doesn't take much movement, right? Simple.
Very simple.
All right. So there I am at the Petri Museum, and there I am with my thread. And I found, well, it's a spiral. Okay, so
you followed it the whole way.
Yeah, followed it the whole way. So I reported on that, and on my website and in message boards, I reported on it. And then I had, no, we don't believe you. You guys could be playing tricks with you, and probably confirmation bias comes into play where you are controlling, you're more in control of where the thread goes than the groove. And I'm like, well, no, that's not the case, but okay.
Number A is a subterranean chamber, which is picking up vibrations deep within the earth. That is transmitting vibrations up those shafts. There's two shafts, one that goes like out of the pyramid to the right, and then one that goes up into the Grand Gallery, and then it goes through the Grand Gallery into the King's Chamber.
Yeah, I mean, okay, the prime impulse in the subchamber, which is A. Okay, so if you're causing or driving a pulse into the earth and eliciting a response, then that's not designed to necessarily be collected just in the subchamber, right? It's designed to affect the whole area under the Great Pyramid, and for vibrations to flow from the earth throughout the 13 acres of the Great Pyramid.
Okay.
And then flow through to the Grand Gallery and also the King's Chamber. So you're collecting those vibrations throughout. And then converting those vibrations into airborne sound, stimulating electron flow from the granite. And I identified the piezoelectric effect as being a principal mechanism for electron flow out of the granite. That changed after I started to do my research on Giza, the Tesla connection.
So what is the specific function of A, the chamber, the subterranean chamber?
In the Giza power plant theory, A is a chamber that contains the means to drive vibrations into the earth.
Okay, so there was there was something inside the chamber underneath the period
Inside the chamber, yes.
that would vibrate the earth.
Yeah. And also at the same time, probably the pyramid. So it would serve two functions. You'd be sending vibrations not just into the earth, but also into the pyramid itself.
Okay.
So, the subchamber being housing the pulse generator, which there are different proposals on that, how that was accomplished.
Okay.
There's one that's uses hydraulics, hydraulic pulse generator. John Cadman, who is a marine engineer out in Bellingham, Washington, is a supporter of that. And then there is the Tesla version, which is what he called an earthquake machine.
Yes, this was a fascinating part of your book. I had no clue.
Electromechanical device that sends timed pulses into a structure, whether it's a beam on a bridge or an I-beam in a building in New York, which I think there's reports that he did that and almost brought the building down.
Yeah, there was a story. You told the story in your book.
Right.
The story was fascinating. They were in the basement of a huge building in New York, and they turned on the generator, and the building started falling down around them.
Right. Well, I don't think anything fell off, but it was threatening to. He had to break the machine. I don't think he
smashed it with a hammer, right?
Yes. And got the hell out of there. Yeah. God. Well, resonance is a really powerful force when you consider it. You know, when you impart energy into a system that is already has a certain amount of energy and is vibrating of a particular frequency, and you catch it at a node, right, a high node. An example would be a pendulum or a swinging ball. Okay, so the swinging ball comes back to you. It reaches the arc height, and then you apply energy right there. Then put energy into it, and it goes further. And so you can start out very, very with very, very small movements of this. Could be a ton, maybe you just move it an inch, and then it swings back to you, and you give it the same amount of force, and it moves 2 inches, and then it comes back to you, and you step back, and each time you're stepping back, and by the time, you can build up quite a swing on that ball without, going up to it and having to smack it with a hammer and probably break the hammer. But the point is that a small child could create quite an effect just by using resonance, and then the whole idea of accumulated energy.
What was
building?
What was the purpose of Tesla's earthquake machine? What was he trying to accomplish with that?
He actually believed and wrote that he thought that you could relieve earthquakes or the severity of earthquakes in the earth. And it was interesting. That was reported. I hadn't read that when I wrote the Giza power plant, because I had made that observation in the Giza power plant that perhaps, with a system for drawing energy out of the earth, one of the effects of that would be the energy that is accumulating in the Earth's plates, where they push together to the point of breaking or rapid release, where you have seismic waves moving out.
So going around with this machine and basically creating little mini earthquakes to avoid some big earthquake down the line.
Yes.
Ah, okay.
Yeah.
Okay, interesting.
Yeah, that that was one, that was one of his ideas about the use of his machine.
Okay.
So basically, that was in alignment with what I was thinking.
Okay. And you imagine something like this was down there in the subterranean chamber?
Yeah.
Okay.
Possibly, yeah.
Okay.
I think everything is open to further research and input from other specialists. I mean,
Right.
obviously, if you're going to start playing around with the planet, you're going to have to have geophysicists involved, and geologists involved, seismologists involved. You know, you can't just willy-nilly go in there and start putting vibrations into the earth in a great quantity. I don't know.
So going back to this grand gallery, you said that Zahi Hawass let you into the pyramid after it had been cleaned, granted you some special access, and you noticed at the ceiling of the grand gallery, which is how many feet tall?
28.
That there were scorch marks.
Yeah, so that's the photograph that I took. Right here, you see those scorch marks. But
Okay, what is this diagram here down on the left?
Okay,
These
so
balls going up.
this is what I wrote in the Giza power plant. Was that there are 27 pairs of slots on the ramps, the side ramps of the Grand Gallery. Okay, so if you look at this area right here, you see the ramps, right?
So that's looking into the grand gallery?
That's looking along the length of it, right?
Okay.
And so I speculated that the Grand Gallery had held these resonators, and I had designed these resonators. I speculated maybe they were Helmholtz resonators, but a resonator that will convert vibration into sound, airborne sound.
Okay.
Now that may not be a Helmholtz, probably wasn't, but it was some device that was caused to move, and as it moved, it produced a sound. That sound was of a particular frequency, and the design of the gallery was such that that sound was naturally focused to that passageway that leads to the King's Chamber. I have the frames, right? And here you see that they line up with the scorch marks. So in the Giza power plant, I proposed that there was a hydrogen explosion in the King's Chamber. And the evidence that exists that prompted me to speculate that was the Petri, when he was doing his measurements, noted that the King's Chamber was expanded. It had expanded from its original dimensions, about half an inch.
And how did that explosion happen, do you think?
Hydrogen explosion. I would speculate that there was a time in history when you had this remarkable civilization that were in possession of advanced science, advanced engineering, advanced mechanical machining, and all of those facilities that we use daily to keep our civilization going existed at some level. Maybe not as sophisticated as ours, maybe more sophisticated as ours. But then there was a cataclysm of some kind. And we're talking about different periods of time in history, whether it's 9,000 years ago, 10,000, 12,000,
Yeah, based on ice cores that have been taken out of Antarctica, they determined that the world was heated up in like an instant to like incredible heat, and then flash frozen instantly after that. And there's been evidence, and people like Randall have done research on this, that they've found evidence of meteors or comets hitting the Earth over a period of 1,000 years. That's called the Younger Dryas.
So that is and then, I think Robert Schoch's view is the coronal mass ejection.
Yes.
So all of those things may have been working at some point in time. The comet strike is probably, I think, for me, the most convincing in terms of the effect that it had on the pyramids, because the pyramids were built, were finely tuned to resonate to the frequencies of the Earth. And so they were drawing energy out of the Earth, there was a known quality. So their relationship was like, okay, we're building it to withstand a certain amount of power to come through it. And then a comet strikes. Right. Okay?
Right.
And so there's, as long as we were a contained system working with known energy levels, everything functioned okay.
Right.
But when you introduce energy from an outside source of such a massive amount, then the coupled oscillator becomes what is known as a runaway vibrator. In other words, it cannot pass through the amount of energy that it is receiving. It just can't handle it.
Which caused the hydrogen explosion.
Which causes, first of all, to probably shuck apart. You have a closed system. The blocks were stripped off the outside. Whatever mechanisms that were attached to the shafts on the outside, the King's Chamber shafts, were removed. It was exposed. Air, oxygen entered into the King's Chamber, mixed with the hydrogen, and then the spark just set it off. Maybe coming from the outside,
right,
and down into the pyramid.
Right. So everything inside, all the intricate parts inside these chambers and these shafts, like the shaft here, would have been fried, causing the scorch marks on the ceiling. Now, when you came up with this diagram of these frames with these round things in the middle, what are those round things supposed to be?
Well, resonators. I identify them as resonators.
Now,
of different frequencies. So they resonate at different frequencies.
And did you come up with this diagram before you saw the scorch marks? Like, did you theorize that that's what it would look like inside the Grand Gallery before you saw those scorch marks?
Well, it was in my book in 1998, and I didn't know about the scorch marks then. And the scorch marks weren't visible until 2001.
When they cleaned it.
After they had cleaned it.
Wow.
Yeah, I mean, there's more too. I don't know if we're going to have time to get it.
Let's go deeper, Mr. Dunn. The large granite boxes that are in the Serapium. And I think you measured them personally by hand. You found out that they were almost perfectly square inside and polished. And they were in this long hallway and separated almost like it was horse stables. And they were kind of like depressed down into the floor a little bit too. And people speculate, or the Egyptologists' theory on this is that those were the tombs, right? That's where they put the mummies.
Supposedly,
that's what they say
for an Apis bull. Yeah, that's the official.
That's the official narrative
for it. Yeah.
Right. Okay. Now, what do you think the purpose of those massive granite boxes with perfect precision? What do you think the purpose was for those?
Supposedly,
That's what they say.
for an apis bowl, yeah. That's the official reason
narrative.
for it. Yeah.
Right. Okay. Now, what do you think the purpose of those massive granite boxes with perfect precision? What do you think the purpose was for those?
You know what the purpose is, or what my speculated purpose is. It's in my book.
Yeah, but this is a podcast. We need it from the horse's mouth. Can you tell the audience what your speculated purpose is? Or are you going to keep that a secret or make them buy the book? If you want to make them buy the book, that's fair.
No, they don't have to buy the book. I mean, they can go to the library. Eventually, it'll end up in Hollywood.
Okay.
Oh, they can download a pirated copy from
Yeah.
Google or
Yeah.
like most people.
So you really don't want to say it?
It's not my theory, so I think
Whose theory is it?
Eric Wilson.
Eric Wilson.
Yeah.
Is he the aerospace engineer?
Yeah. He came up with a brilliant idea. We were down in the tunnels 2018 or 19. And he came up with the idea that they were used for growing crystals.
The aerospace engineer thinks that the boxes were used to grow crystals.
Right.
How?
Good question. So, when you hear something like that, and it doesn't quite settle right away, I can tell it's not settling with you.
Not at all.
Not at all. You're like,
But
right?
I can guarantee you I'm a lot dumber than him, so.
Yeah, that's a pretty safe guarantee. No offense.
Thanks.
So, yeah, and I thought that was an interesting idea. And I kind of expanded on that in my book. But the other interesting thing is related to manufacturing, right? So you go through the tunnels, and you'll find boxes in different stages of manufacture.
Mm-hmm.
Some are roughed in, like they may have been created like that in a quarry before they were shipped, or they could have been loaded and worked on as they were in transit or something like that. We don't know. But there's one box that's stuck down one of the tunnels that has a rough interior, but it's fairly regular in terms of its orthogonality, squareness. I mean, even though the surfaces are definitely rough, you can see that it may have maybe a half inch of material to remove to the final finish and dimensions. We don't know. It's just speculating.
This is evidence that those things would have been finished inside.
I was thinking previously that the boxes were finished underground, but they weren't installed in the crypts. Now it seems that they installed them in the crypts before they finished them, because you find unfinished boxes inside crypts and semi-finished, right? So
Okay.
you got 3 stages of manufacturing. You got the rough finish, or forge finish, or cast finish, quarried finish. Then rough machining, where material is removed to bring it closer to the final dimensions, and then final finishes where the final accuracy is cut into it.
Mm-hmm. Where it becomes reflective.
Yeah. So
Go ahead.
So that's one thing, that finishing those boxes to that precision and then making sure that they stay precise is an objective. They seem to be accommodating by doing them in situ.
Right. So going back to the crystals, how would they have grown crystals inside of those boxes, does he speculate? And for what purpose?
I mean, he didn't elaborate on that, but I did in my book. But it's where you kind of have to stretch your imagination a little bit.
So were these crystals used for the solid state electron harvester pyramid?
Well, it's hard to say. I would say that there are more futuristic and advanced applications for the process if you can develop it, and that is the crystal growth of rocket engines, jet engines, advanced materials using nanotechnology.
The crystal growth of rocket engines, jet engines, and nanotechnology.
Using nanotechnology.
Using nanotechnology.
Yeah, Drexler talks about what he calls them universal assemblers. These are nano machines, right?
Mm-hmm.
That assemble products one atom at a time. And so basically they are used he said that using this technology in the future, you could grow a rocket engine that would have like 10% of the mass of a current rocket engine.
You could grow it.
Grow it, yeah.
Okay. I have no fundamental baseline idea of where this is even coming from. We're not even talking like quantum computers or anything here. We're on a whole nother limb.
It's on a
whole nother branch.
Level.
Yeah.
Yeah. So when you look at the boxes in the Serapium and you're looking on the inside of the boxes, you have the upper part of the box, which is fairly flat, right? On the side of the lid, it's fairly flat. You got, specific dimensions. They may vary a little bit, but essentially, you could look at that assembly, one of the boxes, with a lid on top, as a Cartesian coordinate system.
A Cartesian coordinate system.
Yeah.
What is that?
Well, that's where you have a precise location to reference when you are in three-dimensional space.
Okay.
You got your X, your Y, and your Z.
Right.
Right? And so if you know where you need to be in that three-dimensional space, and you can reference a precise surface in that three-dimensional space, or three surfaces, then you can figure out where you are in three-dimensional space.
Three surfaces.
Yeah, X, Y, Z. So, but you've got.
But that means you would need six surfaces, though, right?
You got five surfaces to work from. Yeah.
Wouldn't you need top, bottom, left, right, front, back?
Don't need bottom.
Why don't you need the bottom?
Top defines the Z. It's science fiction-y.
Yeah.
You could take the book as being a futuristic science fiction look at the future, because one of the things that I do discuss in the book is the validation of the UAPs and these craft that perform amazing miracles of flight.
Yeah, what's more science fiction-y than that?
Yeah, what's more science? But that is real. That's happening in airspace, right?
The large granite boxes that are in the Serapium, And I think you measured them personally by hand. You found out that they were almost perfectly square inside and polished. And they were in this long hallway and separated almost like it was horse stables. And they were kind of like depressed down into the floor a little bit too. And people speculate, or the Egyptologists' theory on this is that those were the tombs, right? That's where they put the mummies.
I got into the one box that had the side had been blasted open, and it was probably the only one that had a corner that was missing on it, and you could crawl in there. Could you put my feet up there?
Yeah. Oh, wow.
So,
okay, is this one solid piece of granite?
Yes, the box itself is crafted out of one solid piece of granite, and the lid probably weighs about 25, 28 tons. Oh. It's huge. And so with that square, I pressed it up against the underside of the lid and up against the inside wall.
Were there any gaps?
No, there was like no gaps. I mean, I'm not saying it was as precise as that instrument. It was just a visual observation.
Right.
But anybody who has done any kind of skilled or precision work who looks at that photograph will be astounded by what they're seeing, because what you're looking at are two surfaces that are parallel to each other, and a flat lid that spans the width of the box.
Right.
So
what caused the corner to break off like that, I wonder?
I think they dynamited it or something like that.
Yeah.
But, the things that are missing from the archaeological record it's not just the means to do the cutting and hollowing out of the box, but also the means to inspect it and measure it to within that kind of level of precision. Even though it may not be perfect, and it may not be perfect throughout, I do put a qualifier in my book that the entire surface needs to be scanned and analyzed completely. Now, Ahmed Adley, who is an Egyptian engineer, went into the Serapium to check me out, and he measured the one box. He was using a digital or a laser distance measure, and then a digital square. I'm not a big fan of digital squares because of the electronics. They tend to drift, and you have to be able to calibrate them. And generally, you would use a square like that to calibrate a digital square.
Do you have any wild ideas to what the purpose of these boxes were?
Oh, yeah. It's in my book.
Let's hear it.
It's wild, too wild.
I love wild. The wilder, the better, Chris.
No, I'm not finished here yet.
Okay, let's keep going. Let's keep going.
Okay. So I think overall my time spent in there was probably 10, 15 minutes, something like that.
What was Zahi saying when he saw you squaring that up like that? Was he?
Oh, he wasn't with me.
I thought you said he went there with you.
No, he stayed back at the Giza Plateau in his office.
Is everything okay, Stephen?
Oh yeah, I'm just stretching.
Oh, okay.
Yeah. So anyway,
and look at that too. Above your hand on the left photo, the reflection of your hand.
Exactly.
That's wild.
Right. So this is an ancient artifact.
How would we recreate this today? Did you talk to any of these big granite manufacturers and ask them their thoughts on this thing?
Well, I contacted 4 granite, precision granite manufacturers. And these companies make granite surface plates and other precise objects like V-blocks, squares, angle plates, and things of that nature.
Okay.
Also, machine beds for variety of machine tools, optical beds and stuff like that. You know, granite is very stable as long as you maintain the correct temperature. And so the only company that responded to my request was a company called Truestone.
Truestone.
Yeah, and they said that they didn't have the means to create one out of a solid piece.
Meaning they would use
They would
5 separate pieces and
They would
bolt
use-
them.
Yeah, 5 separate pieces and bolt them together. And he said the material cost would be, in white, I think they said white granite would be like $175,000, and then there would be Department of Transportation costs would be extremely expensive.
50 grand.
Right, but the the fact that they would not make it out of a solid piece, because if you go to start making these out of solid pieces, then the time for material removal increases, and the difficulties, like even the corners, you're looking at a very, very small radius. It's about 5/32 of an inch radius in the corners. And so there's a lot of consideration when you're looking at a piece like that. But I started to, actually, I think it was in 2013 I was there, and I started to explore other parts of the interior, and I noticed that at the bottom, the precision seemed to fall off a little bit.
On the floor of this thing.
Yeah, near the floor of it. So there was it was obvious that, you know, that the box was not 100% throughout precise, within, I don't know, the tolerance of that gauge or close to it.
Right.
So even if you say, okay, given that the gauge is 50 millions, let's say that the accuracy of the surface is 1/2000th of an inch, which, you know, if it was, you would definitely see light coming through.
1/2000th of an inch.
One or 2,000ths of
That's
an
like
inch.
a human hair?
It's like a human hair, the thickness of a human hair, which is fairly close. It's still extremely precise.
Yes.
And not what you would expect from a primitive culture or an underdeveloped industry or culture.
There's probably nothing in this room that's that precise.
Oh no, there isn't.
Not even a like a MacBook Pro or like a TV. Like, do you think that TV is 1/1,000,000th of an inch, or what was it, 1/1000th of an inch square?
I don't know. It could be.
Just tell me what this was for.
I'm not telling you that yet.
Okay.
Hold your horses.